Is AI really as smart as we think? Apple just dropped a study that could change everything we know about artificial intelligence. It turns out today's AI, whether it's writing, coding, or answering questions, might not be what it seems. In this video, we're digging into Apple's eye-opening findings on AI's true capabilities, and trust me, the reality might surprise you. Let's dive in. So here is the deal. Apple researchers recently published a groundbreaking paper titled GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models. They wanted to know if these AI models actually understand the math they're solving, or if they're just matching patterns from past data. They put this to the test using a popular dataset called GSM 8K, which most models handled with ease. But Apple wasn't satisfied with that. They took it a step further. They created a new, trickier test called GSM Symbolic, where they made tiny tweaks, like changing names or numbers, to see if the models could still solve the problems accurately. They used a clever template passed to the large language model with placeholders that could be swapped with different details to create variations of the same question. It looked something like this. When Name watches her family, she gets out a variety of toys for him. The bag of building blocks has X blocks in it. The bin of stuffed animals has Y stuffed animals inside. The tower of stacking rings has Z multicolored rings on it. Name recently bought a tube of bouncy balls, bringing her total number of toys she bought for her family up to total. How many bouncy balls came in the tube? They used variations like this to test the models, replacing details, changing Sarah to Tom, or changing blocks to cars. Now, you'd think a truly intelligent model could handle that, right? But the results showed something entirely different, and it's not what you'd expect. Long story short, here are the results. On the x-axis, we have the accuracy percentages of each model, and on the y-axis, the frequency of these scores. The original GSM 8K performance is marked by the dashed line on each plot. So, what happened when they made changes in the placeholders? The models showed a surprising drop in performance when the details changed, and the average accuracy on GSM Symbolic was lower than on the original dataset. To dig even deeper, Apple tested several models from top large language models vendors on GSM Symbolic, and the results showed similar trend. It turns out accuracy was all over the place. Apple didn't just stop with small tweaks. They decided to see what would happen if they made these questions harder. They set up 4 difficulty levels: GSM M1, GSM Symb, GSM P1, and GSM P2, with each level adding more complexity. What's interesting is that they designed these levels to see if the models could handle real reasoning, or if they'd buckle under pressure. Here's how it worked. First, GSM M1 removed one clause from the original question, making it a bit easier. Then, GSM Symb had the same base complexity as the standard GSM Symbolic question. Next is, GSM P1 added one extra clause to increase the difficulty, requiring the model to consider an additional detail. Lastly, GSM P2 added 2 extra clauses, making it the most complex version, needing even more reasoning. And here's where it gets really surprising. As the difficulty ramped up, the models didn't just perform worse, they crumbled. The x-axis shows accuracy percentages, and the y-axis is the frequency of those scores across tests. Each line represents a different level of difficulty, from GSM M1 to GSM P2. With every increase in difficulty, the accuracy dropped significantly, and performance became less predictable. If AI were truly reasoning, you'd expect it to adapt to complexity. But instead, the models showed greater instability with each level. It's as if these models hit a wall as soon as they were pushed beyond familiar territory, and the implications of this are huge. So what does all this mean? Apple's findings challenge how we view AI's intelligence. While these models seem impressive, they're often just pattern matching, not reasoning. This raises serious concerns for tasks requiring adaptability or advanced problem solving, like medical diagnostics or critical coding. Relying on AI without understanding its limitations could lead to costly mistakes. But by recognizing these flaws, we can use AI more effectively and responsibly. If you're interested in the practical side of AI, how to make the most of its strengths without falling for the hype, check out my book, Code Wisely, Work Lightly with Generative AI. You'll learn how to create a custom AI assistant with LangChain that more than doubles your coding productivity in Python. This assistant goes beyond tools like ChatGPT and GitHub Copilot by integrating directly into your workflow to handle tasks like data analysis, visualization, and machine learning, all through simple text prompts. With a zero-code approach, this book guides you step by step, from setting up LangChain to designing prompts and securing your data. If you're ready to code smarter, faster, and more securely, click the link in the description to get started. Thanks for watching. If this video opened your eyes to the reality of AI, give it a thumbs up, subscribe for more AI insights, and let me know in the comments. Do you think AI is truly intelligent, or just really good at faking it?